Okay. Hello everyone. Just give me a second here to switch to the right screen. There we go. All right. How's everybody doing tonight? I think we are good to go. So I've done a little bit of audio setup since the last time. So let me know if you guys can hear me okay. Looks like it's going out to the stream okay, but figured I'd just check with you guys. Okay, so where we left off last time was we basically were talking about the implementation of a plugin system. And we're going to be transitioning a lot of things to that plugin system. And I think one of the best ways to actually do this is to sort of work with some existing stuff that we already have. And as a result, I started the setup of a renderer plugin. So I'm actually gonna take those headphones off because there's like a weird echoing. And so what we're gonna do tonight is pick up where we left off in the last video. So last time we actually had set up a new library in here. So we have our typical test bed, and then we now have this Vulkan renderer, which we kind of just set up this main just to make sure that all of our entry points were correct. And so tonight we're going to go ahead and we're going to start actually implementing our plugin and start moving all of our Vulkan code to here. And that will allow us to get rid of all the references to Vulkan in our central library and have our central game engine code not care about what renderer is actually being used. So right now we have sort of this central engine library and we have a renderer and then Vulkan under that. And so the goal here is to basically move all of this stuff out. So what we have currently is we have this front-end, back-end system. So we have a renderer front-end, which is renderer agnostic, and it doesn't know what renderer API we're using in the background. So as far as it knows, it could be Vulkan, it could be DirectX, it could be OpenGL, Metal, whatever. And so you're saying the mic volume is low. Okay, let me... How was that? I think I had the wrong source selected. Appreciate the heads up by the way. Is that much better? Maybe that explains the weird headphone issue I was having. Let me see if it sounds better. Yeah, that does sound better. Okay. Alright, cool. Was it quiet enough that I should basically re-say everything that I was saying, or could you hear what I was saying? Because the thing is this camera up here actually picks up... Yeah, okay. I wondered about that. So this camera up here actually picks up audio as well, and I changed something, and now it is actually feeding into this, potentially. And I think I had that on instead of this actual mic here. So, okay, I will go ahead and restart. So, basically, last time we left off talking about a plugin system that we're going to implement. And the plugin system is going to allow us to extend the engine in various ways that the engine doesn't necessarily have to know or worry about. So that can be anything from our renderer is going to be a plugin, or at least our renderer backend is going to be a plugin. Some other examples of this might be audio or physics. Those can be plugins. And that allows us to sort of remove one and replace it with another. So if we wanted to do a build and use Vulkan, for example, and then have another build and use Metal, for example, we could actually reference different plugins from that and configure that at the application level. if we wanted to use physics for one project and then we wanted to use like a custom physics engine or bullet or something like that, we could use it on a different project, and that would be configurable, and it's basically plug and play. And so we're starting on that with the renderer aspect of it, because the renderer architecture we have so far kind of plays nicely into that. And the whole plugin architecture is something that I've just recently sort of thought up. And so I didn't initially sort of design it with that in mind, but it actually kind of works. So currently what we have is we have this renderer front end and renderer back end system. And the renderer front end is responsible for doing all the generic renderer API agnostic type of work. So it's responsible for handling resizes and issuing draw calls and setting things up like viewport, scissor, creating and destroying textures on a generic level, writing to readable textures. I mean, there's all kinds of stuff in here it does, right? And this is only going to grow as the library does. And so the way that this works is the front end is what interacts with the rest of the engine, and then the back end is what will actually contain our calls to the render API. So it's all sort of wrapped up. Will they be a standalone DLL? So yeah, so that's basically the way that we're gonna do it. And the way that we're gonna set up these plugins is it's not necessarily a one-to-one ratio of plugin to library or DLL. It's basically, you could potentially have multiple plugins in the same DLL if you wanted to, if the plugin is really small, or you have a bunch of really small plugins that you want to implement. They could technically be grouped into a single DLL and handled that way. But at least for right now, we are going to be doing the Vulkan renderer DLL as a standalone. And so that will mean that only for this particular Vulkan renderer project do we have to link with the Vulkan and all that other stuff. So I hope that makes sense. And that is what we are going to set out to at least start tonight. And I should mention that we are on a feature branch for this. So we're calling this feature/plugins. So this is actually going to be available on the repo in a feature branch for those of you that want the code. And then once we finish the feature, we'll go ahead and open up a pull request in the traditional sense on the repo and get that merged into the main branch. So that is basically what we're going to continue with tonight. So last time we actually set up this library, and it's really basic. It just has a couple things in here for me to basically say, are we able to grab our types and other stuff out of the engine library, and can we make a call to this from another library, in this case the game, and we can. And we verified that all those things work. In fact, we can just go ahead and build real quick just to show you what I'm talking about. And we will run. And we see here we get a breakpoint, right? And if we look at the call stack here, we can see that our testbed exe goes from main to create application, and then create application is sort of where we bootstrap our Vulkan main.h and go into our Vulkan renderer DLL. So we have all those connections working correctly. You went with that design in your engine as well. Currently implementing logging as a library. So yeah, that's actually another great example of something that could be a plugin. And in fact, that's actually a really good idea. I probably should convert that to a plugin as well. We also have something that we recently implemented in this engine that is referred to as a console, and then we have console consumers. And so we actually have the ability to input. Let me get rid of some of these breakpoints here. And so we actually have the ability to input commands into this sort of little debug console thing that we have going here. So I can say kvar print all, and it gives me a listing of all the kvars that we have in the system, right? And I can register commands with this and execute them.
and they can all take different amounts of arguments and things like that. And actually, our logger is one of the console consumers, or needs to become a console consumer. So we could technically have that be a console consumer and a plugin at the same time. Or I could just change the concept of a consumer to a plugin and go that route with it. So we have a lot of options. So that really is a good idea. I might actually go that way. That's really good. Okay, so anyway, the other thing that we did, just a quick recap, is we have these two make files. So one is for an executable. That is used for our test bed right now, and it is also used for our test, which is sort of our unit tests, right? And then we also have a library, and that is for all of our DLLs if you're on Windows, for example. And these should work on the other platforms. I haven't actually had a chance to test it since we put this in on Linux and OS X, but I probably will test that offline tonight just to make sure it works. But we basically just go into either the batch file or the sh file, depending on what platform we're on, and we feed it a bunch of arguments, including a whole bunch of stuff for versioning, as well as where the Vulkan SDK is, things like that. So right now we have two different assemblies that are using this library. So we have this engine assembly, which builds our engine DLL, and then we have this Vulkan renderer assembly, which builds that DLL. And so the goal is to remove Vulkan from this one. All right. So that is enough recap, I think. Quite enough recap for now. So let me kill some of these consoles here. And we will get started moving stuff across. So I think probably the first thing that I'm going to do is I'm just going to take, all this Vulkan stuff and just move it all at once, actually. So let's see, Vulkan renderer. Let's do under source, just to keep this consistent with the way we have it in the engine now. I'm going to say, oops, not new file. We want new folder. And I'm going to say renderer. And in that, I'm going to put another new folder called Vulkan. And this might seem a little bit redundant, but it's to kind of keep in line with what we have here, right? So I'm going to take everything in here, and I'm going to move it down here to the Vulkan file. That should be good. So we've moved those. Those are probably going to bleat at me for various pathing issues, I can only imagine. And then I'm also going to delete this guy. So we can go ahead and remove him. And the only other thing that we have to do now is we also have this renderer backend H, which basically just takes in an argument to say create a backend of the given type. This probably is going to be moved to the plugin or the library itself, or at least its functionality will. I haven't quite decided yet. But all it basically does is, if we look here in the renderer backend itself, this has a reference to our Vulkan backend H, which is sort of our main entry point for our backend. And then all it does is basically just set up a huge list of function pointers, right? And so there's nothing really fancy going on here. It just kind of does this, and that's really the end of it. So I think we should be able to just move this to the plugin itself. And then, basically, I think, in fact, you know what? I think I'm going to go ahead and move these, but I'm going to rename them. So we have renderer backend. I'm going to call this, we'll put it in source. Call a new file. Plugin main.h. You know what? Vulkan renderer plugin. Not 100% sold on that name just yet, but we're kind of winging it here a little bit. All right, and so this is going to require render types INL, which is going to be under renderer, render types INL. Why did it get rid of my quotes? Don't know. Do we want to? Yeah, we should probably rename this. You know what? I'm actually not going to rename it for right now. I'm going to keep it the same. Because that kind of does make sense. I suppose... Because realistically, the renderer backend itself is the renderer plugin. So we should probably rename that as well. And then we'll say renderer plugin create. I think that makes a little bit more sense. So yeah, let's actually do that. Renderer backend. We're going to call this renderer plugin. And we'll have a look here at all of the... I'm pretty sure all this is going to be correct. Let's go ahead and rename that. And this is kind of what we're treating as an interface if we had interfaces in C, which we really don't. But if we did, this is kind of what that would be. So we'll say renderer plugin. I'll come back and change the comments, I think, later. I just want to kind of get this working for right now. So the backend C, I'm going to copy this as well and come down here and create another new file, and we'll call this Vulkan renderer plugin main.c. Obviously, we'll need to include the H file. Right. And so this basically just does the same exact thing. This all needs to be changed to renderer. This will need to be changed to core k-memory. In fact, do I actually even need that? Yeah, I do because of this. Okay. By the way, if you guys have any questions along the way, feel free to jump in and ask me questions. This is the idea here is to have this be an interactive stream, so feel free to ask questions along the way, and I will answer them to the best of my ability. Okay, so we have renderer backend. This is going to be that's replaced by that, so that should be fine. Renderer plugin, I think, comes from, yeah, so that's renderer type, so we should be able to leave that there. And now I should be able to actually get rid of these two guys. Right. And ultimately, we're going to have to change some stuff in the front end because that is ultimately what creates the back end. It's in here somewhere. I'm sure it probably hasn't even figured out what's going on yet. All right, so this is basically going to be our main entry point for the plugin. Why is this not picking that up? You know what? Let me build this real quick because IntelliSense sometimes winds up tripping over itself. All right. Oh, you know what? I might have to clean because of all the old objects that are in place. Probably doesn't like that. Okay. So, oh, I forgot about this though. Okay, so there is one thing I forgot about. Crap. So there is one section where the platform layer and the Vulkan layer have to overlap, and that is for the Vulkan surface creation. So this was one thing I didn't think about. So basically that means that there's going to have to be a little bit of platform code in the Vulkan plugin. Or there would have to be a little bit of Vulkan code in the platform, which is what we have now. And this requires Vulkan types for some reason. Let me see why. Let me just remove this because we don't want to have to rely on that. Oh, because it needs the Vulkan context. Right. So this little function right here is the entirety of the problem. Well, that one and this guy. So I think what I'm going to do is I'm going to move this to the plugin. And I had these initially actually sectioned out. And at one point I combined them in here because I thought that made more sense. And now I'm going to wind up splitting it back out. So it happens sometimes, I guess. You think it's better to have the platform in Vulkan? Yeah, I tend to agree. Because you can freely choose the API, but not the platform. Exactly. And so there is a small overlap there, but it's literally like a couple functions, and that's it. So yes, I definitely agree. I'm going to take this stuff out of here because I guess it doesn't really belong here anyways in the first place. So, okay. So I think the way I'm going to set this up is I'm going to set up, because this already exists in platform H. I'm just not gonna. All right. At least I thought I did. Or did I put that in? Oh, I have a separate Vulkan platform. Okay. Which is now moved over. So this actually does make sense to put here. So I'll probably have a Vulkan platform, Win32, Vulkan platform, macOS, Vulkan platform, Linux, and do it that way. I think that makes the most sense. And since this is actually moved to our Vulkan renderer anyway, it's already kind of half there anyways. So that does actually make more sense. All right, so let's start with Windows since we're on that. So I'm going to grab these two functions here. And I'll go to Vulkan platform, wherever that is. And under here, I'm going to create another new folder, which seems kind of asinine, but that actually makes sense to me. Called platform. And this is where I'll dump the C files. So, Vulkan platform win32.c. And then I'll put these in here. I'll have to include, let's see, renderer, Vulkan, and Vulkan platform. Which, you know, let me move this under platform too. It just feels a little bit cleaner to have it there. Defines H, that's going to have to be changed out to that, but this should be fine there. This is now going to be renderer Vulkan platform. Okay, that feels a lot cleaner to me. Let me just build this, see if it stops bleating, at least about some of this stuff. Okay, alright, so this one I expected. So renderer backend, rather. This no longer exists. And if I remove that, it's going to bleat about me trying to create the backend, which is right here. And I actually had a to-do in here to make this configurable. And so basically what we wind up doing here is we create the backend. And this is kind of where we're using like our poor man's dependency injection, if you want to call it that. But this is actually where we should invoke the renderer plugin, which means that we're going to need to know about the plugin existing at this point and initialize it here. So, or actually it would just be creation here, because the plugin actually is going to get initialized here. So, how do I want to do that? So I guess this renderer backend type needs to be added to the application configuration, which I believe we should have. Render system config. Right now all we have is application name for the renderer system config, which is kind of dumb, kind of useless. So let's go ahead and add to that the renderer type. All right, and then I think that should be fine, because now we can say typed configuration renderer type, and then the state pointer backend is now the renderer plugin. So we should actually go here, and we'll just call this plugin. And that's going to be a whole bunch of changes, which should be fine. Yeah, I think all these are probably just string changes, which I'm going to have to evaluate those one by one, so I'm not going to do that right now. But we will rename this to plugin. Right? And now all we'll need to do is have some way to create the plugin by type. But honestly, I'm kind of thinking now that that's a little pointless as well. Because I'm thinking, why do we need to even know about or pass the type here, right? We could just, when we're doing render system initialize, right, that should be in, that's done in the systems manager, render system config. We could put this in the application config as the renderer plugin at that point, and we actually create the plugin during the application boot. This is pre-boot though. Let's see. Boy, okay, I think my auto mod must be going crazy here for a second, because it said, why did it time you out? Yeah, I think my auto mod is being a little bit crazy. So you have an enum of APIs, Vulkan and DirectX, as an argument for render initialization, then load the DLL accordingly. Yeah, I might wind up doing that. The way that I'm thinking of doing this is, since the ultimate consuming application, so you can change APIs at runtime. That is an interesting idea. And theoretically, I could hot reload them at that point. That's not a bad idea, actually. I wasn't thinking of doing that because I was thinking that the application, when it boots, will always know which one it's going to use. So I'm trying to determine if there's a lot of value in me doing that. Because I can't see, I mean, other than the obvious being able to switch renderers without having to relaunch the game, right? But I feel like that's a little bit of a niche thing. I suppose I could support it. Hot reloading is something I don't have in place yet, but it is something I've wanted to put in place, so I'm going to make a note of that and do it on a future pass, because I do actually like that idea. Yeah, I do like that idea. So I've made a note of that. I'm going to basically just move this stuff for now and stick to a sort of just a static load for right now, and then I'm going to circle back to that, because that's actually, that could be useful in certain situations, particularly when doing testing, for example. Okay, so let's see, where was I? So we have the pre-boot that happens here, which is called here. Here we go. So I think we actually do have the application config already. I'm just trying to think of when I would actually realistically need to create the plugin. And I think it would need to happen as soon as possible, at least in the renderer case, because this is technically happening before the game's boot sequence. And I think even if we do wind up being able to hot reload the plugin, it should still be fine to go ahead and boot up with. Yes, okay. So, let's see. So we set up the engine state here. The game instance is passed in. And that should happen right here. So when we do create application, which ultimately happens, so this is actually where we should probably be setting that up. Okay. Although we're actually setting, wait a minute. So at that point it's still null. I think the engine create is actually what fills that out. It's been a while since I've actually looked at this code. It's been better part of a year, actually. Yeah, right there. So we don't have game state until this point, but we could. We could still do it here. If we go to the application itself, we could technically add it here. So I guess we could say renderer plugin. Feels kind of crappy to call it renderer plugin. Not sold on that name, but I'm going to roll with it for now. So this is where that plugin is initially going to live for right now, until we come up with something better. I don't actually have a plugin system in place to actually hold this stuff yet, so this is where I'm going to put it for now. So I'll move that to somewhere better down the road. Okay. So let me get rid of some of this stuff. And instead, we will say, there's the game state, engine state, return true, right. I think right here at the end is actually where we should put that. So render plugin. And this is actually going to be where we stand this up. So we're going to do an include of renderer Vulkan, and then why is my plugin not showing here? Oh, because the plugin's at the top level, that's why. That, okay. So we need that. Did we rename these yet? We did not rename these yet. So Vulkan renderer plugin create. Right, and eventually we're actually going to set up like a nice interface for this to use instead. Because this is not clean yet, but we have to get it working and then we can clean it up. So yeah, we'll go ahead and rename that. And then theoretically, yeah, this is just the destroy for that. So Vulkan renderer plugin destroy. If I can spell. All right. And then this still says renderer backend. That should be plugin. And then out plugin. And plugin. I don't know why the IntelliSense didn't pick up this on the refactor rather. Plugin. Right, let's just replace these real quick. Okay. All right. So I think that should cover us for that. Did the C file do its thing correctly? Maybe. Out plugin. And actually now we don't need this type at all. So actually we don't need any of this. Because we're not switching on that stuff anymore. Plugin. Actually that should be that. Okay, all right, so let me build. I'm sure this is not going to work. I know there's stuff we missed. Well, this looks like render backend. Okay, yeah, that one I knew about. So that's probably going to be the next thing, is to hook that up. So let's go over to, let's actually go back to our entry and create the renderer plugin. So Vulkan renderer plugin create, and we're just going to pass the address of outGame renderer plugin. And I believe that returns a boolean, so we need to check that to make sure that it was successful. And mind you, this is only creating the plugin, so this is basically just setting up function pointers at this point, and that's it. There's no actually initialization happening. That's a separate step. So we'll just return false here. Because at this point we don't have any logging or anything like that. So at this point, if it just fails, we shut down the whole thing. Why is that still saying type? where does it think that's coming from? Oh, because I haven't removed type out of here. Right. So we don't need that. We don't need a type. What is this bleating about now? Render types. That should be fine. It's picking it up, obviously. Alright, let me just build one more time just so I can get a clean log here. So basically what I'm going to do is, as I'm moving the stuff, I'm just going to resolve these errors one by one. And it looks like this renderer front end one is going to be the next thing that we have to take care of. So by this point, we should already have the plugin created. So we shouldn't actually have to do this at all anymore. So that should actually be able to go away. Right, because the plugin would have been created already. Looks like we got a couple things here. Renderer backend not found. Well, yeah, that's Vulkan backend. Oh, right. Why does it need that actually? Do we use the? Yeah, we do use the plugin here. Okay, so that's actually going to need to be at the base level. So that's going to be Vulkan renderer plugin main. So that should fix that one. In fact, actually, what else are we missing here? File not found. Oh, because I have quotes and angle brackets. What a dingus. Okay. Vulkan platform.h. So, oh, this is because that's moved to platform. So, alright, getting somewhere. Alright, so, oh, all these errors are going to be because we literally have just not included things like Vulkan, oops, Vulkan.h, and include Vulkan, is it win? I thought it was Vulkan win32.h, I think is what it was. I think is what I had there. Or was it Vulkan? Vulkan.h? This is also going to need Windows. I'm going to guess that's going to need to come first. Windows.h. Alright. Vulkan context it doesn't have. So that's going to need... you know what? This should probably be down here. Include... we need Vulkan renderer. Actually, we need Vulkan types, don't we? So it's going to be renderer, Vulkan types. I know. Let's put that there. Okay. So now the only thing we have left, oh, we also need D-array. Include core D-array. Oh, .h. This isn't C++. Oh man. Okay, you know what? I don't know what is going on with my Autobot here. Give me a second to resolve that, because I don't know why it's like killing your messages for some reason. And I'm guessing it's probably because you like put an enumeration or something in there. Give me 1 second here. All right, let's see. So I think it was the Streamlabs auto mod being a little bit sus tonight for some reason. So let's see. Where is the... Yeah, okay, found that one. Let's go... Let's try that. All right. We'll give that a shot. If you don't mind, if you could just try sending your last message again. And I don't get why it's deleting all of your messages either. I might just wind up turning this thing off if it's too aggressive. Anyway. Okay. So that's the array. Oh, it's containers, not core. All right. Now the only thing that we have remaining here is this state pointer business. And the state pointer is a bit of an issue because, and this might be the reason that I actually combined this stuff before. So the state pointer is basically this guy. It's our platform state. And it holds the operating system specific stuff, if you will. So in our case, it holds the H instance and the H-wind. And those are things that are specific to Windows. The macOS platform has got its own bunch of stuff that it has to hold on to, all this stuff, right? And Linux has a whole bunch of its stuff for like XCB and the X Windows system. Boy, I just realized the bot timed you out for 300 seconds, which is kind of ridiculous. Sorry about that. I'm still trying to figure out how all this stuff works. So, you know what? Let's do... I'm going to turn this stuff off, and I'll figure it out once somebody is actually being a bananas or something. Okay, so I don't know when it did that, so I guess just wait until the timeout is finished, and then send another message if you don't mind. But I've disabled all that stuff for now, so again, sorry about that. It's kind of getting in the way, I suppose. I will... Yeah, muted you for 5 minutes. Saying to define lean and mean on Windows.h. Yeah, I think I actually had that up here. I thought it did somewhere. Maybe I nuked it. Didn't I have that in here somewhere? Apparently I did not. Wow. Why not? I think it's Win32 lean and mean, I want to say. Just looking it up real quick because I can't remember exactly what it was supposed to be, and it's been a while. It's like one of those things you only do once. Yeah, okay. So we will do there. And this is actually, I wonder if I have to do this twice. I think I might have to because we're doing it in 2 different libraries. So technically I'd need to do it here as well. Right here. Yeah, Win32 lean and mean. Bot didn't like the macro being capitalized. Yeah, that's exactly what it was. There's a setting in there for that. And then there's also apparently like settings where it like ups the amount of times that it mutes you for different things. It said that it also killed some of your messages for being too long. I don't know what it considers too long, so I'm gonna have to look into that, and then I will I'll look into it and re-enable all that stuff once I figure it out. I just kind of went with the default settings, and I suppose that's what I get for not looking into it further. Okay, so I guess what I really need to do here is I need a way to extract these things from the platform layer. Because what we have here is a static, and this is one of the reasons I wanted to get away from static state pointers. Because that way we don't have to have this kind of weird, stupid thing happening. So we have this state, which is basically just, that's what state pointer becomes, right? Like it's allocated when this platform system is started up. So we do actually have this accessible elsewhere, but the problem is we don't have the type for this, nor do I really want to expose it here. Because I don't want necessarily all these types obviously to be exposed in the H file, because obviously that means we'd have to pull windows and all that other crap, and I don't want to do that. So what I'm thinking is, do I need actually both of these? Or do I only need one? If I only need one, this actually becomes really easy. No, of course I need both. All right. So what I'm thinking is, I might just literally cold cast into like another structure type that I declare here on this side, and literally pull out the bytes and get the pointers that way. Not ideal, but I do want the encapsulation here. And I can't think of another way to do it without having to expose these types to the rest of the engine. So that anything that included platform H would get these, and I really don't want to do that. Do I need anything other than window? Yeah, so that's the thing. I need the H instance and the H wind. Right here for the surface. I need both. Because I was going to say if it was just one, then I could just do a void pointer and cold cast it. I mean, I suppose I could do 2 void pointers and cold cast them. Because I think the other... What do the other platforms need? So... This one requires the connection in the window. So that requires 2 things as well. And I'll bet the Mac one does as well. Oh, the Mac thing actually only requires 1. Yeah, DirectX doesn't use H instance, but apparently Vulkan does. I don't know if it actually does require that internally or not. You know what? Let's look that up, because maybe I'm doing all this for nothing. So let's do let's see. So this is the create info. It doesn't say whether or not it's optional. Oh, okay. Yeah, so we do need both for valid usage, unfortunately. So, can't you query H instance from the application? I could, but the other thing that I'm thinking is we might eventually wind up having like a multi-window system. And I'm thinking if we do that, you know, these would be different potentially. Well, I think this would be the same, but this might not be. Or maybe it's opposite of that. I can't remember. It's been a while since I've done any serious Win32 programming. But yeah, I'm pretty sure I think if I'm going to do the work to expose one, I might as well just expose both. Because let me see for the Linux one, what's the Linux one called? For XCB. I think that's going to wind up being something similar. Yeah, see, XCB also requires both. So I suppose what I could do is I could go in here and basically just copy into like a void pointer just all the bytes of whatever we need into one package, and then tell it on the other side how big that thing is, and then just cold cast it. And just use the size of it to sort of verify what we're doing. It seems a little bit hacky, but I don't know. Querying it just seems just as hacky to me. So, alright, so what I'm going to do is I'm going to structure this a little bit differently. I'm going to come here, type def a new structure, handle info, I guess. I'll call it Win32. Win32 handle info. And in that, I will put these. And then do that. And then I can just basically pass this thing over and redeclare that on the other side. I think that's probably going to be the best way to do it. So that just means that I need to say handle dot, not all this other stuff, which is not a huge deal. And it means I'll have to update the other platforms to do something similar, but that's, again, not a huge deal. Yeah, that should be fine. And then just redeclare this on the other side. Right. And then I can just make something to expose that in the platform state. So in the platform Win32, I could just have something like like return a const pointer, I guess. Yeah, it should be fine. Win32. Actually, no, it should just be platform. Oh wait, I can't do that because it's got to be, oh, right, what am I doing? This needs to be void platform get handle info. And then we'll just pass void pointer memory and I guess I'll do a U64 out size. Actually, let me set this up like the Vulkan API actually does, right? So we can call this twice and say always set the size, right? So we could say out size equals size of this, right? And then if we don't pass memory, then we just return. Otherwise, we do I not have memory here? Oh, I did. Nope, I don't. Include core kmemory.h. Copy memory. The destination is going to be memory. The source is going to be state pointer handle. And the size is going to be out size. That's going to be address of handle, actually. Right, okay. So basically, the idea is that this is a trick that the Vulkan API uses a lot, where you basically call something twice. You call once to get the size of the memory, and then passing 0 to the actual memory pointer itself. And this is basically a way of saying how big, how much memory do I need to have allocated. And then you go ahead and allocate that memory, and then you call this function again, passing that allocated block here, and then you just copy the block of data over. And then from there, on the other side, you can basically just take that memory block, cold cast it to what you need, and you're good to go. It does result in an extra allocation, but this is creating a surface, which is not something that we have to do quickly or a lot of. So I think I'm okay with it. So let me go ahead and add this to platform.h. Where should I put this? I should probably put this towards the bottom, quite honestly. Let's put it there. Right, so obtains the required memory amount for platform specific handle data, and optionally obtains a copy of that data. Call twice, once with memory equals 0 to obtain size, then a second time where memory equals allocated block. Right, a pointer to hold the memory requirement. Allocated block of memory. Why do I keep typing 2 M's in memory? I don't know. Alright. I'm satisfied with that. That should work. That should give me everything I need. So, at this point, now I should be able to move this to the bottom, actually, just to be consistent with everything else. There's all the mutex stuff. Processor count right here. Put that there. So that should do that, and then I should be able to include the actual platform. Platform H. And from there, get the platform get handle info. Right, and that is going to need a U64 size. Start that off at 0, so we'll pass the address of size. Pass 0 for the allocated block of memory the first time we call it. I need my memory for memory. Then here we can say kallocate size, and then mem tag. Oops. What do I want to situate this underneath? Let's go with a renderer on that. All right. Void block equals kallocate. Then we'll go ahead and call this again. Passing block this time. IntelliSense is like super freaking out over all these changes. Doesn't know how to keep up with it. Alright, so now that we have that, we can cold cast to the handle info. So we can say handle equals block. Right, and at that point we should have the data here written to it. So now all we should have to do is, first off, check to make sure we have a handle. And then instead of this state pointer business, it'll just be handle, h instance, and h wind. Shoot, we didn't do the surface. Now I wonder if doesn't the context also has a surface. Why are we storing that in the platform? Do we actually use... No, we don't. Yeah, so we don't actually have any need for this whatsoever. We don't need that there at all, which I guess means I really didn't need the struct, but whatever, it's a little bit more organized now anyway. So all the surface info now is removed out of platform 132. Which means this handle, the handle isn't what should have the surface, because that's actually stored in the context. So when we create that, we're going to create that directly to the context. We don't need this copy operation anymore. I'm not sure why I did it that way. That should fix it. Let's build. Oh, right, because I don't have the logger in here. Which I guess the logger hasn't been initialized at this point, but it should still write out to the console. So I'm going to keep it in there anyways. Include core logger. Unresolved external symbols. Those are always fun. All right. Vulkan backend.c. Wait, I thought we got rid of that. Did we not? Oh wait, this guy. What is this bleating about? Render buffer create. Oh. Because... Wait, is this not linked with the engine? It should be. Render backend initial. Yeah, let me take a look at... Let me actually search for this real quick. So, technically the way this works, and this is a little bit weird, I guess, is, well, I guess it's not that weird. This render buffer create is a front end function, and it does things like it creates the free list on the front end, which is a front end thing. It's agnostic of whatever backend we're using, and then it goes on and creates the internal buffer from the back end, or what's now the plugin. And so this is actually saying that we have an unreferenced external symbol, which means that we're probably not linking with the engine. It's the only thing I can think of. So let me have a look at the build file, because I wonder. So we have additional include flags, additional linker flags. So I'm definitely thinking that somewhere in here, maybe it's here, we're just not passing, whoops, not that one, this one. Maybe we are not passing well, we are linking with the engine. Let me clean and rebuild this because we've done a lot of changing and moving around. What am I missing here? It's going to be something stupid. Probably something in here. Well, wait a minute. That's the test bed. This is the renderer lib. This line. We are linking with the engine. Okay. The engine is being built first, so that shouldn't be an issue. Oh, you know what? I'll bet those functions aren't being exported. I'll bet that's what it is. Okay, so render buffer create. Let's just see. That's what it is. Okay. Yeah, yep. The K API, exactly. Yeah, I was like, I thought I set this up correctly, but these do not have the K API. So probably just about everything on here should probably, whoops, have that. And I initially didn't have it that way because I was like, oh, nothing else will have to reference the renderer, but that's kind of dumb because everything will have to reference the renderer at some point. Even application code, because there may be applications that need to do specific things with the renderer that maybe the renderer wasn't set up to do initially. So actually, I'm going to export just about everything off of here. this one too. Oops. Sure, why not? Probably should have just done this from the get-go. And the really annoying thing is I don't actually have to do this on Linux. It's just a Visual Studio thing, because Visual Studio by default does not export. Which, I guess, depending on how you look at it, is a good or a bad thing. Suppose I could have done some sort of fancy find and replace, but I don't know. It's not that big of a deal to just do this manually real quick. Oops. Almost done. If I can actually select the lines, that would be great. Okay. Alright, that should be good. Okay, not surprised about these ones either. So that's the texture system. It's probably also missing exports. Which I suppose the texture system really ought to have everything exported as well, except for initialize and shut down. Because that shouldn't really be ever needed outside the engine. So go ahead and export all of this stuff. I was wondering at some point if this was ever going to bite me by not just exporting all this stuff, and here we are. Alright, platform get hand. Oh, I didn't do that one, really? Alright, now what am I missing? Vulkan renderer plugin create, referenced in function create application. Oh. Right. These also need to be exported because they are called from the application. Alright, we built. I don't know why this is bleating. What are you complaining about? Probably IntelliSense again. Okay. Yeah, it's just, alright, whatever. I'm gonna ignore that for now. Let's see if it runs. Negative. So, did I not? Alright, let me step through this code. Probably just didn't assign something somewhere. Right, so these all have addresses. Okay, so that's fine. So I'm just going to skip past those. So our plugin should have all this stuff assigned. It does. All those have addresses. That looks fine. Okay. The application instance. Oh, wait a minute. Render plugin. Yeah, the render plugin is good to go. Yeah, that should be fine. Why is it not? Oh, I probably forgot to... The state pointer plugin. I didn't copy it over from type config, I'll bet. Nope, that just has renderer type. Did I not? Let's see. Oh, so the... Right. Render... That's app config. I didn't copy it from the app config over. So whenever I go here to register that plugin, system render config. Yeah, this is what actually needs to have the plugin so that the... first off, let's get rid of this backend type. This is actually not used anymore, anywhere. And we'll say renderer plugin. Right, we're going to have a couple copies of this, but I think that's fine. Because all it really is function pointers. We just have to get it from point A to point B. And this will go away, so I'm fine with that. Renderer system initialize. Let's go back to here. Plugin equals app config. Whoops. Whoops. Didn't I have the plugin here? Or was it the... Shoot. What level was that at? I thought the app config was what had it. Oh, it's the game instance that has it. Right? Render plugin. Systems initializer. Let's see, the app config is here. Do I do anything stupid like zero it out in here? I don't think so. It's going to be a second level of copy down though. I'm not a huge fan of that. All right, let me do it that way for now. I'm not really a huge fan of it, but yeah, I guess I really need to application config. All right, so we'll pass the render plugin this way. And then once we go into Systems Manager Initialize, when we initialize known systems, namely the renderer, we will set the plugin to app config plugin. And that should probably be called renderer plugin. Be specific. At that point, that should have that, and then in the renderer front end C, we set up the state pointer. We will also set up the state pointer plugin to equal the typed config plugin. And I believe that will give us everything we need. Let's do a save all. Well, you gotta go. Gotta work early in the morning tomorrow. Have a nice stream. Watch the rest later. Well, thank you so much for stopping by. I really appreciate you, having input and programming along with me here. Definitely great to have you here. So I'll see you on the next stream then. Have a good one. I think we're actually getting to the point here where we're almost done getting this plugin to run. So let's see. So I'm just gonna kill all the breakpoints right quick and see. Aha! We are up and running. So we actually have our Vulkan renderer now split out from the main engine into a library of its own, and then loading through kind of a hacky way of loading it because we don't have an actual plugin system created yet, but we are able to sort of load this through a plugin interface that we've started. So that is awesome. Me born. Woo, yes, woo indeed. I wasn't 100% sure that was going to work the first time I ran it, but it did. So that's pretty awesome. So definitely really cool. So let me think about what I want to actually do next. We can remove all Vulkan references from the engine library. So that is probably the next logical step. So let me go in here to this, and all we should have to do is in the engine itself, we can remove, actually the only additional include flags we had here was for Vulkan, so we can actually completely kill that. We don't need that anymore. Additional link flags was also only for Vulkan stuff, so we can actually remove that as well. So that actually makes our engine a lot simpler to build, which is neat. And so the Vulkan renderer now is responsible for linking with the engine and linking with the Vulkan libraries, which is exactly what we want. So I'm going to do a quick just clean real fast, just to make sure that we are indeed starting from nothing. And I'll do a rebuild, and we'll see where we wind up. Alright, looks like we built successfully. Let's just run. And there we go. So we are up and running, which is awesome. So our different lighting modes work as well. Our different debug display modes, that is. So all of that seems to work exactly as expected, which is pretty sweet. Alright. So I think with that, probably what I'm going to do is just get all this checked in for now. And then we can start thinking about what else we kind of want to move around into a plugin. Now, Taman had mentioned the idea of moving the logger to a plugin, which I think is a fantastic idea. So that's probably the next thing that we'll do. And then we can start implementing some more interesting type plugins, like I'm thinking like audio. Audio is probably going to be one that we want to do soon, even if we don't do anything fancy with it, just to kind of get our feet wet with creating plugins. And then another thing that people keep bringing up a lot is scripting language, which I actually don't have much interest in doing a scripting language, at least in the engine's core, but if somebody wanted to buy a plugin, we could do it that way. So Let me think. What else? I guess the next step would probably be to maybe figure out our plugin interface a little bit better, and then maybe get rid of this entry business that we're doing here, where we create this plugin this way. We might be better off implementing our hot reload at this point. Which incidentally, the back end here is, I believe, also using a static variable for its state, I think. Yes. So we're using this sort of static Vulkan context object, which is going to be bad if we actually want to support hot reloading. So that's probably the next thing that we're going to wind up having to get rid of, is this static data. Whoops. Potentially native C scripting with hot reloaded or animation system. Yes, actually. So native C scripting is actually what I'm shooting for with hot reloading. So at least initially, the core engine itself is not going to be hot reloadable, because I actually have some work to do to actually get that set up so it's actually going to work with that. So right now we have a lot of these static state objects sort of all over the place, and I did that to encapsulate things a little bit better. But now that we actually have a systems manager that actually has a copy of all those state pointer objects, what I'm going to do is implement something in there to be able to actually obtain the state from that state manager for the specific type of object, and then we don't need to do this anymore because we'll actually have a pointer to the memory of the thing. So before I can do hot reloading, I've got to do that, and then from that point we can do hot reloading. And this Vulkan library is probably the first. I'm thinking it'll be the first library where we can actually do that. And I'll have to think of maybe some clever tests that we could do. But yeah, hot reloading is definitely going to be a thing. We are also going to set up the game libraries or the application libraries to use. All of their logic will be moved to a separate library of their own, which will be hot reloadable as well. So right now, like, we have our test bed that has a lot of random stuff in it about keybinds and all this stuff. And if we don't want to change that, right now we have to reboot. And so this is an example that we'll probably try to hot reload as well, and move that off to a hot reloadable, I guess, game library or application library. I may not do that with testbed. I haven't really decided yet. I might do that with the editor or our game application that we actually are going to be standing up here shortly. So we'll figure that out. All right. With all of that said, though, I think probably this is where I'm going to wrap things up for tonight, I think. So I guess before I do any of that, do any of you guys, that are watching, have any questions or comments or ways that I can improve the stream or anything like that? I want to keep this interactive as possible, and I'm trying to get in the habit of saying that throughout the stream. It's just sometimes I get a little bit focused on my coding. But yeah, if you guys have any questions or comments, feel free to drop them in the chat, and I do try to read that quite often. In the meantime, okay. So we will. I think we are still on the right branch here. Yeah, it's plugins. Oops, get add star. Vulkan logic moved to separate DLL/plugin. Right. Actually, I should just be able to do this because it should already exist there. Okay. So now I should be able to also do a pull request. Let me grab a logged in window real quick. Pull this down. All right. So we're going to be merging into main. I'm just going to do a quick look here at all of... Now this is actually going to contain everything I did in this video and the last video. Let's see. Keep it up. I've been using some of the techniques of my own hobby engine development learning. Planning on adding more streams to the schedule. So right now, the only one that I can officially schedule right now is Wednesdays, just due to, you know, IRL responsibilities and things of that nature. However, I do try to also stream on Thursday nights when I can, and occasionally on the weekends. So I do occasionally have extra streams when I do have extra time. But for right now, I'm just sort of getting my feet wet with this whole thing, and so I'm committing to 1 day a week, and if I can do more, I will do more, basically, for right now. And that's basically the same schedule that I had on my YouTube channel. So if you're not aware, my YouTube channel is basically where all this stuff will be archived. So I stream here, and then I'll download the VOD, upload it to YouTube, and that gets released on a weekly basis, essentially. So this will eventually be up on YouTube as well. I hope that answers your question. So this actually contains all the changes that we made to the make files to make them generic, and all that other stuff that we did in terms of window changes, all the file moves. I think it's safe to say I could just merge this. I'm glad I did look at this. I don't want to check this rubbish in, right? So the Vulkan main H and C files. I thought I got rid of those, but apparently I did not. So let me get rid of these guys. Okay, I hate how it always scrolls this window away from what you're doing. Alright, so get status. Removed unnecessary files. Okay. Alright, so let me just refresh this pull request. We had, what, 41 files, so now it should be 39. Yeah, okay. And this is part of the reason I do it this way, right? So in this case, the changes that I made last time were somewhat breaking. And I wasn't able to finish all the changes in one stream. So what I'm going to do whenever I run into that is basically just do a feature branch, and then when the feature is complete, or at least complete enough to move into main, where we have code that's usable that runs, I'll go ahead and move that over. So I should point out, for anybody that is watching this, this is only done for Windows. So I will need to also do this for Linux, but well, Linux and macOS. And probably what I'm going to wind up doing is I probably will just do those offline, and just basically go over a pull request on the next stream, simply because I don't really want to have to reboot. I don't have like a separate streaming PC. So I would have to like reboot this box to do the Linux version, and then hook up the Mac and try and stream off of that. It's just not worth it. So I will probably fix those two off stream, and then set up another PR and go that route with it. So let's go ahead and create the pull request. Now this says merging is blocked, but since I am the owner, I can squash and merge. And we see my commits here, so I'll go ahead and leave those, and we will go ahead and confirm squash and merge. And now all this stuff is in the main branch. So the changes that I'll make for the other platforms, I'll probably make separate branches for those with separate PRs. And like I said, I'll just go over those on the next stream. Cool. So that pretty much wraps it up for tonight. I wasn't actually sure I was going to get all this done tonight, but I did wind up getting that done. I guess one thing I could go over real quick for anybody that is still here is there is a KohiEngine.com that serves as sort of a central hub to everything that we have about the project. So you could follow it on the YouTube. I need to add Twitch here as well. We have a Discord. Here's the GitHub repo. If you want, you could support me on Patreon. I greatly appreciate that. The latest videos that have been uploaded to YouTube, as well as some auto-generated API documentation. So this has got like all the data structures that we have in there. A lot of them, not all of them, are commented, but I've made a pretty decent effort to comment as much as possible. So it's got all the data structures, data fields, files if you want to go by files or file list. And for right now, this does only contain the actual engine, but this has got, you know, documentation on all the functions here, right? And so there's that. And then there's also a community page, which is basically a forum. This is not very active or very used. I don't know if I'm going to leave this up. It's just not something that has been used a whole heck of a lot. So I may or may not wind up keeping this. If you guys start using it, I'll certainly leave it up. My thought behind this was hopefully that questions or things that you guys run into could be posted here for people in the future that run into a similar problem. They could search the forum and maybe find those answers. Whereas, you know, if it gets buried on Discord or something, it may be a little bit harder to find. But yeah, so I think that is about it. So unless you guys have any more questions, I'll probably go ahead and wrap up the stream a little bit early tonight. I want to say thank you guys so much for tuning in. Your support is greatly appreciated. If you haven't already, you know, and you like the content here, please toss me a follow. That helps a lot. Also, word of mouth helps a lot too. So please spread the word about my Twitch channel here. I'm trying to grow it. So any way that I can reach more people and hopefully help people understand what goes into writing a game engine and eventually a game, because that is the goal here. Is we want to make games with this engine. We don't want to just build an engine for random purposes, right? We want to build and release games. So if that is interesting to you, or you know somebody that you feel that will be interesting to them, feel free to spread the word. I would greatly appreciate it. Of course, you can find me on all the other usual places. So you can find me on Twitter, Instagram. I don't really check my Facebook all that often, but I am on there as well. And yeah, I think that is about going to do it for tonight. So cool. Thank you guys so much for watching. And let's see. You know what? Let me go ahead and see if I can find a channel to raid here. Let me see if there is anybody that is doing development right now, and maybe I can raid their channel. Let's see. I'm just going to look really quickly here under software and game development. Let's see who is online. You know what? I liked this guy's stream the other day, so let me do. I'm gonna raid Durley D. He's working on a pretty cool looking game, and I really like the visual style of it, and he's really nice to listen to. So I'm gonna go ahead and raid his channel real quick. So this is the first time I'm doing this too. All right, and yeah, I'll see you guys later. Thanks.